Hello everyone, I Dr. Kirti Sahu welcome you all to this video lecture on differential equation. As we know, many practical problems in science and engineering are formulated by finding how one quantity is related to or depends upon one or more quantities defined in the problem. Often it is easier to model a relation between the rate of change in the variables rather than between the variables themselves. The transition from a given physical problem to its mathematical representation is called modeling. The study of this relationship gives rise to a differential equation. The concept of differential equation is of great interest to the engineer, physicist, or the computer scientist. So differential equations have a remarkable ability to predict world around us. They are used in a wide variety of discipline, right from biology, economics, physics, chemistry up to engineering. They can describe the exponential growth and the decay, the population growth of the species, or the change in the investment return over the time. So differential equation is very important for us. Some of the uses of differential equation includes in medicine for modeling cancer growth or the spread of the disease, in engineering for the describing the movement of the electricity, in chemistry for modeling chemical reactions and to compute the radioactive half-life, whereas in physics to describe the motion of waves, pendulums and the chaotic system. It is also used in physics with Newton's second law of motion and the law of cooling. In Hooke's law for modeling the motion of a spring, or in representing models for population growth and the money flow or the circulation. So with this vast applications of differential equation, let us know what is the objective of this learning video. So here in this video lecture we will learn about what is mean by a differential equation, then what are the types of differential equation, and how to find out the order and degree of differential equations. So let us see first what exactly a differential equation and how it is defined. So in a layman language, an equation containing a derivatives or differential coefficients is called a differential equation. Differential equations plays a fundamental role in engineering because many physical phenomena are best formulated mathematically in terms of their rate of change. So here is an example of the differential equation where v is a dependent variable and t is a independent variables. So with this base, the differential equation is defined mathematically as an equation which contains the derivative of one or more dependent variables with respect to one or more independent variables is called a differential equation. So here are the couple of examples of differential equation in various forms. So based on the type of derivative involved in a differential equation, the differential equation is categorized into two types basically, that is ordinary differential equation and a partial differential equation. So ordinary differential equations contains a derivative. So here is an example which contains a ordinary derivative. So here we will find the dependency of the function on only one independent variables. That is, this involves the ordinary derivative of unknown functions. Whereas in case of partial differential equation, we will find the partial derivative where a dependent variable depends on more than one independent variable. So with this base, let us see how exactly the ordinary differential equations and partial differential equations are defined. So any equation containing ordinary derivative, that is the derivative of dependent variable with respect to a single independent variable. Note, in a case of ordinary differential equation, we have only one dependent variable and one independent variable. So here are the examples of the ordinary differential equation. Here the unknown function is x of t. You can find x depends on t, so this is unknown function which depends on t, so t is a independent variable and x is a dependent variable. Similarly, the differential equation containing partial derivatives, that is the derivative of the dependent variable with respect to two or more independent variable, is called partial differential equation. So here is an example of the partial differential equation where u is a dependent variable and x and y are the independent variables. Whereas in these two examples you will find u as a dependent variable and x and t are the independent variables. Now let us see what do we mean by order of differential equation. So order of differential equation means the order of highest order derivative occurring in the differential equation. So here we have the examples of differential equations where we will see how to find the order of differential equations. So here you will find that we find two derivative term, one is d2y by dx square whereas another is dy by dx. So first order derivative and second order derivative, out of which highest of them is a second order derivative. Hence the order of differential equation is 2. In this way we can find out the order of differential equations as mentioned below. So here in the second example, the highest order derivative term is d2y by dx square whereas in the third one it is d3y by dx cube. Let us move to the next definition, that is degree of differential equation. So the degree of differential equation is nothing but the exponent or the power, the positive integral power of the highest order derivative occurring in the differential equation. So let us see for the same example how to get the degree. Note here, for finding the degree of differential equation, the derivative terms or the equation must be made free from the radical or the fractional powers as far as the derivatives are concerned. So here in this example you can see we find a radical sign. So first of all this needs to be made free from this radical sign. So for this first of all we will take cube root and then the square root. So this result into this equation. So find out the highest derivative term. Highest derivative term is this one. Just see its power. So power is 2, hence the degree is 2. Similarly, here the highest derivative term is d3y by dx cube whose power is 1 or the exponent is 1. So degree of differential equation is 1. Now in this case highest order derivative term is this. So just look for its power. Power is 3. Hence the degree of this differential equation is 3. Whereas for the next example the degree comes out to be 1. So let us try to understand the concept of evaluating the order and degree of the differential equation with a couple of examples. So let us see the first example. Determine the order and degree of the differential equation. So first we will go for the rules required. So before evaluating the order and degree, we will have to make the equation free from the radical sign. So here we find this radical sign. So what we do, we will shift all other terms on the left hand side except that radical sign term. So this is the term. Now after this just remove this radical sign. So for this we need to take the square. Taking square and then go for the derivative term. So here we have first order derivative term. Here also the first order derivative term. Right. So therefore the order of derivative over here is nothing but 1, whereas the power of the first order derivative terms is nothing but 2, right? Whereas here it is 1, so we will see the highest of them, that is 2. Therefore, the order of the differential equation is 1 and the degree is 2. Let us have the next example. Here also, as here the fractional power is mentioned, so let us remove this fractional power. So I just have to take the square on both the side. So we have this simplified form. Over here, just see the highest order derivative term, that is d4y by dx4. So order of derivative is 4, and just look for its highest power or the exponent, so that is 2, hence the degree is 2. So in this way we have come to an end of the video. So let us quickly revise what we have learned in this video lecture. So we have seen what is mean by differential equation, what are its importance, then we have seen how to find out how to categorize the differential equations, and then we have learned how to get the order and the degree of any differential equation. So I hope this video you will find important, not only for the exam point of view, but also for getting the basic knowledge which is required for the other topics as well. So with this note, I am ending the video. Thank you all for watching the video.